All right. Good afternoon, everyone, and welcome to our live webinar from Curriculum Pathways. Today we'll be talking about coding across the curriculum using CodeSnaps, which is a free app for iPad available from the App Store from Curriculum Pathways. Just to dive in a little bit, give you some background before we get into the computer science side of things. Just want to tell you a little bit about Curriculum Pathways itself. So we are a repository of over 1,800 resources, all for K-12 in the 5 core disciplines, and we get to give them all away for free. So our repository includes lessons as well as tools and apps. Everything is standards aligned, and we're constantly updating it and looking for feedback. So please go use it, sign up with your free account, and let us know what you think. Curriculum Pathways by the numbers looks something like this. So like I said, we're in the 5 core disciplines, all standards aligned. We have over 4 million registered users coming from 133 countries in all 50 states. We have 9 native iPad apps, one of which is CodeSnaps, 3 Chromebook apps, 1 Google Doc add-on, and 1 Microsoft add-in. But why do we care so much about computer science? So CodeSnaps is our one and only computer science education app to complement our other resources. And we're involved in computer science for a few reasons. One, at the heart, we are a technology company. So we are a philanthropic division of a large privately owned software company called SAS. And we obviously are interested in the future of technology and the next generation of computer scientists. So computer science education has been one of our focus for education outreach. But also computer science is the most prolific industry. Computer science touches almost every single thing that we do. And we talk about STEM and the shortage of personnel going into STEM fields, especially females. But when we actually look at the numbers, it paints a slightly different picture. So when we think about STEM being science, technology, engineering, and math, and we look at the different graduate degrees being offered in those areas, you see here on this graph, which was published in the New York Times back in November of last year, you see the blue lines indicating the number of graduates in those majors. So we have a lot of folks graduating in the life sciences, which would include things like nursing and medicine. A lot of people graduating with engineering degrees, the physical sciences, as well as math. And some folks graduating with computer science as well. But the pink lines indicate job openings. So in every other STEM discipline, the number of graduates is outpacing the number of available jobs except for computer science, which is such an indicator to the growing industry. So now is the best time as any to get going with computer science, and it's one of the most useful and relevant skills we can be teaching our students today. But there's some major barriers to computer science education. So it's not something that's been in the curriculum for years like math or English. And we're really still trying to figure out how to fit it in. The day is already packed. It's not like teachers are waiting around saying, what should I do with this extra 30 minutes? There are several barriers to integrating computer science despite its popularity. So one of which is limited technology. So in order to teach computer science, you need technology. Students need to be able to practice programming. They need to be able to understand devices, have access to high-speed internet. And while the picture is getting better, several students still have limited access to technology. Schools are still facing technology shortages or just dealing with older versions of technologies that aren't running the latest and greatest. The second, and this is a big one, is no time. So like I said, there's no teacher sitting around waiting, trying to figure out what to do with the extra time in the day. It's already a jam-packed schedule. There's already the course of study that teachers have to teach. So adding another discipline is just out of the question. So there's been some talk, should it be just an elective, which seems to marginalize the importance of computer science? Should it be a foreign language, which has some pros and cons with it as well? Or should it be integrated across the curriculum like writing, for example. In every single discipline, we integrate writing. And so should we be treating computer science the same way? And if so, how? Because our teachers just aren't being trained in teaching computer science. So it's not something that a lot of people had in their own formal schooling. So there's a lot of self-efficacy issues, people feeling intimidated by teaching computer science. But also the pre-service teacher, the colleges of education just haven't caught up necessarily with the best way to integrate computer science themselves. So is it a specialty? Is it integrated across like writing or reading? It's just not clear yet, and there's really not a consensus. So right now it's being offered as a supplemental professional development opportunity for teachers, and adding one more thing to their plate generally isn't high on people's lists. So how and when to integrate computer science education professional development is very much an open question. But for all of these reasons, we at SAS Curriculum Pathways wanted to help. So we came up with CodeSnaps, and I'll show you a quick video just to give you an overview of CodeSnaps.
Looking for a fun, low-budget way to introduce coding to your class? Look no further than SAS CodeSnaps. SAS CodeSnaps is a collaborative coding environment requiring only one robot and one iPad. Students work in groups to solve coding challenges using printed, tangible CodeSnaps blocks that, when scanned by the CodeSnaps app, can be executed by the connected robot. Get creative and have fun with SAS CodeSnaps, a new way to code.
So that's SAS CodeSnaps. Like I said, we're trying to address those three barriers that we talked about: time, teacher training, as well as access to technology. So as you heard in the video, CodeSnaps is a low-budget solution for computer science education, and we'll talk a little bit more about each of those. So let's start with access to technology. As you saw in the video, CodeSnaps takes advantage of these printed tangible blocks. So students are actually coding with physical paper blocks as opposed to on the device themselves. And so CodeSnaps allows an entire room of students to code together using only one iPad and one robot. So the teacher has the iPad and the robot, and the students are all coding using the paper blocks. These paper blocks look identical to the blocks found in the app itself. They're also identical to block-based programming languages that they're familiar with in other resources. So it transfers very nicely to the computer. But instead of having to have a device per student, we're actually having students use paper, which is slightly more readily available for teachers. So as you're coding with the blocks, as you can see there, you basically take a picture of them, scan the blocks in, and it translates it directly into the CodeSnaps app. So you can see those blocks that are there on the table. After scanning it in, show up in the coding interface on the right. So the right is a screenshot of CodeSnaps. And you can see there the code is in there. There's a play button at the bottom, but there's also coding blocks to the left. So you can edit your code. So if there's a scanning error or students don't have the blocks themselves, that's fine because you can just use the app as well. So you can just drag and drop those blocks onto the screen and just press play. A great benefit of this as well is not only do students not have access to devices, but internet is always an issue. Even though schools many schools are running high-speed broadband internet, it can be unreliable, and we hear this time and time again from teachers. They don't want to put the fate of an entire lesson in the hands of the school's internet. But CodeSnaps doesn't use Wi-Fi. So you only have to have the Bluetooth connection from CodeSnaps app to the Sphero itself. So you can do everything that we're describing out in the middle of a field if you want to. It is Wi-Fi agnostic. Now I'm going to turn it over to my colleague Jen, who's going to talk about the other constraints.
Hello.
Yep, so as Lucy mentioned, the main constraints were technology, time, and teacher training. And time is definitely the one we hear most when we talk to teachers ourselves. Their day is packed, they have to hit their standards and all of the core disciplines, and they just don't see how they can weave it in. And so that is why we have worked to develop what we call our Coding Across the Curriculum suite of lessons, which is really designed to introduce coding into the core disciplines, into the electives, so you don't have to take time out of the day to focus on coding. You can code while you're learning math concepts, while you're assessing what they've learned in social studies and things like that. Here, we've got just a few examples of some of these lessons that we've done. For example, here we have a math lesson where students are navigating an obstacle course, but they have to solve some mathematical equations in order to know how far the robot needs to travel. Sometimes we've also set up math problems that have to be solved. Like on the right-hand side, this is called the 24 problem, and they have to figure out how to get through the course by adding, dividing, subtracting numbers to reach 24 as the final result. And so they're having to solve those problems to come up with the path before they then program the robot to navigate it. Here are some examples using ELA and music. So we have coding of stories like The Very Hungry Caterpillar. We've done exercises using a grid where students have to find rhyming words and word families within the grid. So for example, in this image, you can see they have to get through the grid landing only on at words. So this is a great way for them to show their understanding of word families and that recognition, and then do a fun coding activity on top of that. And then finally, the last picture is coding the Itsy Bitsy Spider. So this could be both language arts and telling a story, or music, as you can see in this video. As you can hear, there's some very excited kindergartners who wrote code to do the Itsy Bitsy Spider. So they're having an engaging activity in their core and elective classes, but still getting to code at the same time. Here's another example that we did in both science and Spanish. On the left, you can see we set up a course that looks like the 4 seasons. And so we talked about the seasons and how they cycle every year. We had students code the robot to go through those seasons, and we talked about loops and other coding constructs within that. But then we also did this as a Spanish foreign language exercise as well. So Curriculum Pathways, we have a great video series on Spanish lessons, and one of them is on the seasons. So we had students watch that and learn about the seasons, learn some vocabulary related to it, like it's hot, it is snowing, things like that. And then we had them use that vocabulary and also write their code using our Spanish language blocks to help bring home the colors and all of the language concepts while they were engaging in this lesson. CodeSnaps does have printed blocks available in several languages, including Spanish, Italian, German, simplified Mandarin, French. I think that's it, in addition to English. And so this is a great way to support language learning, including English as a second language. You can have students code in whatever language is most natural for them, and they'll still be engaging in the same activity. And related to time, in addition to integrating CodeSnaps into the core disciplines, we've thought a lot about how it relates to other key skills that students need to learn. For example, the 21st century skills, often called the 4 C's of communication, collaboration, critical thinking, and creativity. We see all the time that most computer science lessons always involve creativity and critical thinking. It's just a natural part of what it means to solve a coding challenge or a computer science problem. But a lot of times these activities are done independently, and so there aren't opportunities for communication or collaboration. And we think CodeSnaps helps a lot with that. We've also worked on understanding how CodeSnaps can improve spatial reasoning, which is a key STEM skill. It is very important as students progress in their math and science courses to have spatial reasoning to be able to represent problems. And so CodeSnaps is a great challenge for improving those skills as well. For collaboration and communication, we often have students work together in teams that mimic the teams that we have when we're developing software. And so they're no longer working independently. They're having to communicate information back and forth because they each have a specific role. Another important thing that happens here with the collaboration and communication is the tangible coding blocks can really support a different kind of collaborative environment than most computer science platforms, which are just on one device and are not physical and tangible. That's because, two students can easily hand each other blocks, can be both working on the problem at the same time, whereas in a traditional digital environment, they might be able to share the mouse, but that's not exactly collaboration and teamwork in the same way. As far as spatial reasoning goes, CodeSnaps is full of this because it is a real-world environment where you are navigating a robot in space. And so when we have obstacle courses, students have to measure, they have to create representations of the space and of the challenge. And this gets at skills like map making. Perspective taking is another key skill that students engage in. They have to take the perspective of the robot to know whether this is a left turn or a right turn, especially as a robot gets further and further into the code and might be facing different ways as it's navigated. This can become a very challenging problem for young students and adults to reason about where the robot needs to go next and what direction that is relative to the robot. And again, a lot of research has shown that communication and talking about spatial concepts and verbally explaining using spatial language is really important for how spatial reasoning develops. So it's great that we're supporting both the spatial reasoning and the collaboration and communication pieces together. And then finally, we want to touch on the teacher training component. So as I mentioned, we have all of these lessons that we've built for coding across the curriculum, and you can find detailed lesson plans for how to implement all of these on our website. If you just go to the CodeSnaps resource online, and we can show you how to do that, you'll see a listing of all of the lessons that have been built to go along with that. And there's details in there about setup, things you need to know to help a teacher who may not be comfortable teaching computer science be able to integrate it into their classroom. We also have a suite of videos that support using the app and can detail some of our lesson plans and things like that. For example, we have a very detailed video about how to set up and conduct one of our most popular lessons, which is navigating an obstacle course. So we'll go ahead and play that video for you now.
Welcome to CodeSnaps, a fun and engaging activity for your students to learn basic concepts in programming and robotics. In this basic collaborative coding activity, students are challenged to work in groups and navigate a robot through an obstacle course. The robot should travel from the start line to the finish line. When the robot hits a colored spot, it should change to the color of the spot.
To set up this activity, identify a start line. From there, measure a distance to the 1/10 of a meter from the start line to the first obstacle. Repeat this process for the remaining obstacles and the finish line. To begin the activity with students, present the challenge and divide them into groups. Have students identify who will be the product manager, the lead coder, and the tester. The product manager is in charge of measuring and writing out the necessary steps for navigating the course. The lead coder is in charge of translating the product manager's notes into code using the CodeSnaps blocks. The tester is in charge of running the code and documenting any bugs. Ask the product managers to come forward and measure the course. They should document all distances, turns, and color changes. When finished, the product managers return to their groups and present their findings. From there, the lead coder gets to work collaborating with the rest of the team on writing the program. When the program is complete, the code is ready to be scanned. Scanning the code with the CodeSnaps app is simple. Tap Scan Blocks. Line up the CodeSnaps blocks between the guiding lines. Press Start. Slowly work your way down the code, paying close attention to the green boxes. A green box means the QR code was captured by the app. Sometimes the green boxes disappear. That's okay, as long as it turned green once. You can move the device in and out to capture stubborn codes. Just be sure to move slowly and steadily as you do. When you reach the end of your code, press Stop. Be sure to do this before moving your iPad away from your program. Review the code that was scanned. You can import the code into your project or try scanning again if there were errors. Once you import the code, you can edit it directly in the editor if necessary. Now, you're ready to run the code. Ask the tester to line the robot up on the start line. Use the orientation button to face the robot in the right position. The blue light is a tail light and should face in the opposite direction of your definition of forward. After the tester presses the play button, they should document any bugs and report them back to the group. In the app and on curriculumpathways.com, you'll find ready-to-print PDFs of CodeSnaps blocks in 6 different languages, as well as other CodeSnaps lessons, including our Show with Code series, designed to integrate coding across the curriculum. Get creative and get coding with CodeSnaps, a new way to code.
This is what you see. It's a list of all of your projects. There is an option to log in. Logging in simply syncs all of your projects across devices, so it stores everything in the cloud. So depending on your technology integration, if you are using a cart or shared devices, the login option is a nice feature. But if you're not, that's fine too. It all works the same way. So if I go here to robot settings at the top, you can see now it's looking for a Sphero to connect to. You see that we support Sphero and Spark, as well as Ollies and Spark Pluses. So the instructions for connecting to any of those devices are listed here. When you're actually connected to a device, you'll be prompted to do a 3-step calibration process. This calibration process basically teaches Sphero the concept of meters. So CodeSnaps allow students to program in meters as opposed to time and speed like other Sphero applications. So in order to do that, we have to teach Sphero meters. And unfortunately, Sphero is sensitive to different floor surfaces. So his concept of a meter might look a little bit different on the carpet versus a linoleum floor, for example. So anytime you're on a new floor surface, you'll need to recalibrate your Sphero. It's a quick process that that takes only a couple of minutes, and once you see the calibration metric, you can generally just type that in automatically, and the calibration wizard walks you right through that. When you have students coding, all you do is hit New Project, give it a name, And you see now that we're in the coding environment. So this is a drag and drop environment here where I can just drag codes onto the screen, snap them together to make a program, tap the numbers to change any of the variables. And when the sphere is connected, you press play at the bottom of the screen. That scan blocks button that was available in the video is available up here. When I hit scan blocks, it's going to bring up the camera and you can go through and scan the blocks. And that's it. It's a very simple app, but it has a lot of possibilities. As Jen mentioned, there's really a ton of different activities you could do across the curriculum to integrate computer science as a way of students demonstrating mastery, the way that we feel about writing, for example, right now. So instead of writing a paper, you could have students write a program that navigates spheros through a certain obstacle course. You could draw maps on the floor. You could have a human digestive system on the floor where students are navigating spheros through those. And in order to do it correctly, they'd have to demonstrate mastery of the concept. So presented on the screen now are our contact information. If you have any questions, please don't hesitate to email either myself or Jen or the Curriculum Pathways email. If you are running a CodeSnap session, we'd love to see it and retweet it and share it with our friends. So please tag us at SAS Educator on Twitter. We'd love to see pictures. For more information, including this recorded demo, you can find it at curriculumpathways.com. For more information about CodeSnaps, head to curriculumpathways.com/CodeSnaps. Thank you so much for joining us today.